Hello everyone, I'm Professor Diwa, and welcome to a math video on solving nonlinear systems of equations. Our objectives are to solve a nonlinear system using substitution, solve a nonlinear system using elimination. Alright, so let's go ahead and get started. Example number 1, solve each system using substitution. For part A, we have the system of equations, y equals the square root of x, and we also have x squared plus y squared equals 6. We're going to use substitution to solve this system. The first step is solving one equation for either the variable x or y. In this case, the top equation is already solved for y, so we can move on to substituting our value for y into the other equation. So we get x squared plus parentheses square root of x squared equals 6. Next, we simplify by taking the square of the square root of x. The result is x squared plus x equals 6. Next, we set the equation equal to 0 by subtracting 6 from both sides of the equation. The result is x squared plus x minus 6 equals 0. Next, we factor. We get parentheses x plus 3 times parentheses x minus 2 equals 0. Next, we use the zero factor property. We get x plus 3 equals 0 and x minus 2 equals 0. Solving the first equation for x, we subtract 3 from both sides of the equation. The result is x equals negative 3. Solving the second equation for x, we add 2 to both sides of the equation. The result is x equals 2. Next, we need to find the corresponding y values. For x equals negative 3, we plug this into the equation y equals the square root of x. We get y equals the square root of negative 3, which is not a real number. So x equals negative 3 is not going to be a solution. Next, we move on to x equals 2. We get y equals the square root of 3. So we only have one solution, which is at the point parentheses 2 comma square root of 3. Just to give you a better intuition of what's going on, graphically, this solution represents the intersection of our system of equations. Over here, we have the graph of y equals the square root of x, and we also have the graph of x squared plus y squared equals 6. This is just a circle centered at 0, 0 with a radius of length square root of 6. You can see here on the graph, the intersection takes place in quadrant 1 at the point 2, root 3. Moving on to part B, we have the system of equations x plus y equals 3 and x squared plus y squared equals 4. To solve this system of equations, we're going to start by solving the top equation for y. To solve for y, we just subtract x from both sides of the equation. The result is y equals negative x plus 3. Next, we're going to substitute our value for y into the other equation. We get x squared plus parentheses negative x plus 3 squared equals 4. The next step is simplifying by squaring the negative x plus 3. This is a perfect square, so we get x squared minus 6x plus 9, and then we bring down all the other terms. The result is x squared plus x squared minus 6x plus 9 equals 4. From here, we combine like terms. X squared plus x squared is 2x squared, and then we bring down all the other terms. The result is 2x squared minus 6x plus 9 equals 4. Next, we set the equation equal to 0 by subtracting 4 from both sides of the equation. The result is 2x squared minus 6x plus 5 equals 0. The next step is factoring the trinomial. However, it's not factorable by using the x method, star method, or even the guess and check method. So we're going to use the quadratic formula. The value for a is 2, the value for b is negative 6, the value for c is 5. Next, we substitute these values into the quadratic formula. We get x equals negative parentheses negative 6 plus or minus the square root of negative 6 squared minus 4 times 2 times 5 all over 2 times 2. Next, we simplify. Minus a negative 6 becomes positive 6. Negative 6 squared is 36. Minus 4 times 5 times 2 is negative 40. 2 times 2 is 4. The result is x equals 6 plus or minus the square root of 36 minus 40 over 4. From here we subtract 40 from 36, which is negative 4, so we get x equals 6 plus or minus the square root of negative 4 over 6. Next we could rewrite the square root of negative 4 as 2i. The final result is x equals 6 plus or minus 2i over 6. Because the result is a complex number, this means that there are no real solutions for this system. If we take a look at what's happening graphically, the top equation of our system is just a linear equation. Written in slope-intercept form, we have y equals negative x plus 3. This is a line with the slope of negative 1 and a y-intercept of 3. You could see here on the left, we have a graph of this line in blue. The second equation in our system, x squared plus y squared equals 4, is a circle with the center at 0, 0 and a radius of 2. So we have the graph of the circle here in red. So you could see here visually that the two graphs do not intersect, meaning that there is no solution to this system. Next, we have a practice problem. Solve each system using substitution. For part A, we have the system of equations y equals negative square root of x and the equation x squared plus y squared equals 20. For part B, we have the system of equations x minus y equals 5 and x squared plus y squared equals 9. Alright, so go ahead and pause the video, solve each system, and then check back with the video to see the solutions. Alright, so let's go ahead and go over the solutions. For part A, we start by taking the top equation, y equals the negative square root of x, and substitute that into the bottom equation. The result is x squared plus parentheses negative square root of x squared equals 20. After taking the square of negative square root of x, we get x squared plus x equals 20. Next, we set the equation equal to 0 by subtracting 20 from both sides. The result is x squared plus x minus 20 equals 0. Next, we factor. We get parentheses x plus 5 times parentheses x minus 4 equals 0. Next, we apply the zero factor property. We get x plus 5 equals 0 and x minus 4 equals 0. Solving the first equation for x, we subtract 5 from both sides. The result is x equals negative 5. Solving the second equation for x, we add 4 to both sides. The result is x equals 4. Next, we need to find the corresponding y values. Starting with x equals negative 5, we substitute this value into the equation y equals negative square root of x. We get y equals negative square root of negative 5. The result is not a real number, so we're not going to include this in our solution. Next, we move on to x equals 4. We just substitute 4 into the equation for y equals negative square root of x. We get y equals negative square root of 4. After simplifying, we get y equals negative 2. So there's only one solution, which is the point parentheses 4 comma negative 2. Moving on to part B, I started by solving the top equation for x. We just add y to both sides. The result is x equals y plus 5. Next, we substitute this value into the bottom equation. We get parentheses y plus 5 squared plus y squared equals 9. Next, we simplify the y plus 5 squared. We just multiply it out as a perfect square and then bring down all the other terms. The result is y squared plus 10y plus 25 plus y squared equals 9. Next, we simplify by combining like terms. We just add together the two y squareds to get 2y squared and then bring down all the other terms. We get 2y squared plus 10y plus 25 equals 9. Next, we set the equation equal to 0 by subtracting 9 from both sides. The result is 2y squared plus 10y plus 16 equals 0. Next, we factor out a common factor of 2 from all the terms. We get 2 times the parentheses, y squared plus 5y plus 8 equals 0. From here, if we tried to factor the trinomial inside the parentheses, you'd see you would not be able to factor this using the x method or guess and check method. So that means we have to use the quadratic formula. The value for a is going to be 1, the value for b is 5, and the value for c is 8. Substituting these values into the quadratic formula, we get x equals -5 plus or minus the square root of 5 squared minus 4 times 1 times 8 all over 2 times 1. Next, we simplify. We get 5 squared is 25. We have minus 4 times 1 times 8 is -32. 2 times 1 is 2. The result is x equals -5 plus or minus the square root of 25 minus 32 all over 2. Next, we have 25 minus 32, which is -7. So we get x equals -5 plus or minus the square root of -7 over 2. Next, we could simplify the square root of -7 as I root 7. The final result is x equals -5 plus or minus I root 7 over 2. Because the result is a complex number, this means that there are no real solutions. Next, we have example number 2. Solve the system by elimination. We have the system of equations x squared plus 2y squared equals 10, and the equation x squared minus y squared equals 1. To solve this using elimination, I'm going to call the top equation E1 and the bottom equation E2. From here, we could eliminate the x squared variable by subtracting E2 from E1. So I have E1, which is x squared plus 2y squared equals 10, and then minus E2, which is -x squared plus y squared equals -1. Next, we do the elimination. The x squareds will cancel out. We have 2y squared plus y squared is 3y squared, and 10 minus 1 is 9. The result is 3y squared equals 9. Next, we go ahead and solve for y. We just divide both sides by 3. We get 3y squared over 3 equals 9 over 3. After simplifying, we get y squared equals 3. Next, we get rid of the square by taking the square root of both sides of the equation. The result is y equals plus or minus the square root of 3. From here, we need to find the corresponding x values. To find the corresponding values of x, we just substitute in both values for y, the plus minus root 3, into the first equation. We get x squared plus 2 times the parentheses plus minus root 3 squared equals 10. Next, we take the square of plus minus root 3. The square of positive root 3 will be 3. The square of negative root 3 will also be 3. So we get x squared plus 2 times 3 equals 10. Next, we do the multiplication. 2 times 3 is 6, so the result is x squared plus 6 equals 10. Next, we solve for x squared by subtracting 6 from both sides of the equation. The result is x squared equals 4. Next, we need to get rid of the square by taking the square root of both sides of the equation. The result is x equals plus or minus 2. So this results in 4 total solutions. For x equals positive 2, we get the 2 points, parentheses 2 comma root 3, and parentheses 2 comma negative root 3. For x equals negative 2, we also get 2 points. We get parentheses negative 2 comma root 3, and parentheses negative 2 comma negative root 3. Now, just to show you what's going on graphically with this solution, I have a diagram here on the right. The top equation, x squared plus 2y squared equals 10, is the graph of an ellipse that we have in red. The bottom equation, x squared minus y squared equals 1, is the graph of a hyperbola that you see here in blue. The solution of this system is all the points where these two graphs intersect. You can see here that there's 4 intersection points, 1 in each quadrant. In quadrant 1, we have 2 comma root 3. In quadrant 2, we have negative 2 comma root 3. In quadrant 3, we have negative 2 comma negative root 3. And in quadrant 4, we have 2 comma negative root 3. Next, we have a practice problem. Solve the system by elimination. We have the system of equations x squared plus 4y squared equals 16. We also have the equation x squared minus y squared equals 6. Alright, so go ahead and pause the video, solve this system by elimination, and then check back with the video to see the solutions. Alright, so let's go ahead and go over the solutions. For this system of equations, I labeled the top equation E1 and the bottom equation E2. We're going to start by eliminating the x squared variable. To do this, we just take E1 and subtract E2. So E1 is x squared plus 4y squared equals 16, and then minus E2 is negative x squared plus y squared equals negative 6. Next, we do the elimination. The x squareds will cancel out. We have 4y squared plus y squared is 5y squared, and 16 minus 6 is positive 10. The result is 5y squared equals 10. Next, we need to solve for y squared, so we divide both sides by 5. We get 5y squared over 5 equals 10 over 5. After simplifying, we get y squared equals 2. Next, we need to get rid of the square by taking the square root of both sides of the equation. The result is y equals plus or minus the square root of 2. Next, we need to find the corresponding x values. We just take the y value of plus minus square root of 2 and we substitute it into the first equation for y. We get x squared plus 4 times the parentheses plus or minus the square root of 2 squared equals 16. Next, we take the square of plus minus square root of 2. The square of positive root 2 is just 2. The square of negative root 2 will still be positive 2. So the result is x squared plus 4 times 2 equals 16. Next, we do the multiplication. 4 times 2 is 8. The result is x squared plus 8 equals 16. Next, we need to isolate x by itself. So we need to get rid of the positive 8 by subtracting 8 from both sides. The result is x squared equals 8. Next, we get rid of the square by taking the square root of both sides. The result is x equals plus or minus square root of 8. We could rewrite the square root of 8 as 2 root 2. So the final result is x equals plus or minus 2 root 2. This results in 4 different solutions. For positive 2 root 2, we have 2 points, which are parentheses 2 root 2, comma negative root 2, and parentheses 2 root 2, comma root 2. For negative 2 root 2, we also get 2 more points. We get parentheses negative 2 root 2, comma negative root 2, and parentheses negative 2 root 2, comma root 2. Example number 3, solve the system. Here we have the system of equations, x squared minus 3y equals 1, and x minus y equals 1. To solve this system, it's not possible to do elimination because we don't have the same variable terms for both equations. So we have to use the substitution method. First, I'm going to solve the bottom equation for x by adding y to both sides of the equation. The result is x equals y plus 1. Next, we're going to substitute that value into the top equation. We get parentheses y plus 1 squared minus 3y equals 1. Next, we multiply out the y plus 1 squared as a perfect square and then bring down all the other terms. The result is y squared plus 2y plus 1 minus 3y equals 1. Next, we combine like terms with the 2y and the minus 3y to get negative y, and then bring down all the other terms. The result is y squared minus y plus 1 equals 1. Next, we set the equation equal to 0 by subtracting 1 from both sides. The result is y squared minus y equals 0. Next, we can factor out a common factor of y. We get y times the parentheses y minus 1 equals 0. From here, we apply the zero factor property. We get y minus 1 equals 0 and y equals 0. Solving the first equation for y, we add 1 to both sides. The result is y equals 1. Next, we need to find the corresponding x values. So we take y equals 1 and substitute it into the equation x equals y plus 1. We get x equals 0 plus 1, which is equal to 1. Next, we take the value of y equals 0 and substitute it into the same equation. We get x equals 1 plus 1, which is equal to 2. This results in two solutions. So we have 2 points, one at parentheses 1, 0, and the other point at parentheses 2, 1. If we look on the right, we can see the graphical representation of the system and our solution. The first equation, x squared minus 3y equals 1, is the graph of the parabola in red. The second equation, x minus y equals 1, is the graph of the line in blue. You can see that the solution is the intersection between these two graphs, which takes place at 1, 0 and 2, 1. Next, we have a practice problem. Solve the system. We have the system of equations x squared minus 4y equals 4, and the equation x plus y equals negative 1. Alright, so go ahead and pause the video, solve this system, and check back with the video to see the solutions. Alright, so let's go ahead and go over the solutions. To solve this system, we're going to use substitution. So I first started off by solving the bottom equation for y. To solve for y, I just subtracted x from both sides of the equation. The result is y equals negative x minus 1. Next, we take our value for y and substitute it into the top equation. The result is x squared minus 4 times the parentheses minus x minus 1 equals 4. The next step is distributing the minus 4 inside the parentheses to the minus x and the minus 1. The result is x squared plus 4x plus 4 equals 4. Next, we set the equation equal to 0 by subtracting 4 from both sides. The result is x squared plus 4x equals 0. From here, we can factor out a common factor of x. The result is x times the parentheses, x plus 4 equals 0. Next, we apply the zero factor property. We get x equals 0 and x plus 4 equals 0. Solving the second equation for x, we just subtract 4 from both sides. The result is x equals negative 4. From here, we need to find the corresponding y values. Starting with x equals 0, we just plug this value into the equation y equals negative x minus 1. We get y equals negative 0 minus 1, which gives us y equals negative 1. Next, we find the corresponding y value for x equals negative 4. We just take negative 4 and plug it into the same equation. We get y equals negative parentheses negative 4 minus 1. After simplifying, we get y equals 3. This results in two solutions. We have 2 points. We have one point at parentheses 0, negative 1, and the other point at parentheses negative 4, 3. Alright, well this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.